Welcome, my dear student. So, in this lecture series, I am going to solve you some of the interesting problems from your JEE Advanced perspective. So, let us start with this. So, there is a bead of mass 0.1 kg which can slide without friction on a vertical hoop of radius capital R. Okay. So, this is a vertical hoop. Inside that, there is a small bead is placed over here whose mass is given and it can slide along this hoop without friction. The bead moves under the combined influence of gravity and the spring of natural length R. So bead is connected with the spring. So this is the spring part. So the bead is connected with the spring at the bottommost point. So the bead can move with the combined action of the spring force as well as the gravity. That means both are conservative in nature. So for the spring, it is given that the natural length is R and the spring constant value is given as 1 by root 2 minus 1, that number, attached to the bottom of the hoop. So initially the bead is released at the top. Okay, so bead is released from the topmost point of the hoop and with negligible speed. Okay, now you are asked to calculate the velocity of the bead once it reaches at point A. Okay, so that means you release the bead from, let us say this is the B point, and gradually the bead will follow this path and reach at point A. So once the particle reaches at point A, you are asked to calculate what is the velocity. Let us say you take the reference line from B and reference line. So this is the point A. So from B to A, we apply the energy bound for B to A. So what we write, since only the combined of gravity and the spring force are there, so only conservative forces are there. So what is the potential energy at point B? Initial potential energy plus kinetic energy at point B. That should be equal to final potential energy at point A plus final kinetic energy at point B. Okay, so there is the work energy conservation theorem applied for conservative forces only. So since I take the reference line at passing to the point B, can I take the initial potential energy of the particle due to gravitation is 0? But the spring is stretched by a length of 2r. So at point B, the elongation of the spring is basically 2r minus r. Why? Because r is the natural length. So can I write that is equals to half k into 2r minus r whole square. And initially the particle is released from rest. So kinetic energy is 0. So this is the initial energy. Now finally, once the particle reaches at point A, okay, so potential energy is reduced. Gravitational potential energy is reduced by how much distance? R. Because distance between point A and point B is R. So I write mgr with a negative sign. And what is the spring potential energy? That is half K. Now what is X? X is at the point A, the spring is like this. This is the position of the spring. So that length is how much? R root 2. So this is the R root 2 length. So this length is R root 2. Now R root 2 is clearly more than R. So that means the elongation is how much? R root 2 minus R. So R root 2 minus R, that is the elongation whole square. Okay. And finally the kinetic energy at point B, that is half m into V naught square. That V naught number you want to calculate. So you are asked to calculate the velocity of the bead, that will give the value of answer V naught. Okay. Now you have to simplify it. So for simplification, this number is 2r minus r means r square. So I am writing half k into r square plus mgr plus half k, and then r square take common. So it becomes root 2 minus 1 whole square with a minus sign. Here you have to use one minus sign because I have changed the sign. So it is minus. Okay. And that should be equal to how much? That is equal to half m into V naught square. Okay. So if I take this part and this part together, I take half k r square common. Half k r square common. So that should be 1 minus root 2 minus 1 whole square. Plus mgr. That number is there. And that should be equal to half m into V naught square. Okay. So root 2 minus 1 into 1. So that gives the 1. So this is 1 plus a minus b whole square means 2 plus 1 minus 3 plus 2 root 2. Okay. So that number, that is multiplied by k r square by 2 plus mgr. That should be equal to half m V naught square. Okay. Half m V naught square. So finally what you are getting that root 3 minus 1 is 2. So take 2 common. So root 2 minus 1. So 2 will cancel out. So ultimately k r square into root 2 minus 1 plus mgr equals to half m V naught square. Now it is given that k number is how much? 1 by root 2 minus. So if you put 1 by root 2 minus 1, so root 2 minus 1 cancels off. So we are left with only r square. So finally answer is equals to, I can write, so half m v naught square, that should be equals to how much? mgr is there, plus r square simply. Now put the value of r. R is equals to 1. So r is 1 and m is 0.1. So 0.1 into 10 and r is 1. So this is 1. So 1 plus 1 means 2. Okay. So m v naught square equals to how much? 4. And m is equals to 0.1. So v naught square equals to 4 by 0.1. 4 by 1. Okay. So 0.1 means 1 by 10, that is 40. So v naught square becomes 40. So v naught becomes 2 root 10 meter per second. That is the answer of the speed once the bead will reach at point A. Okay. So simply you have to apply the conservation of energy principle, and in this situation only the conservative forces are there. So you take only the effect of potential energy and kinetic energy. No other forces are there. Okay. So that means it will be answer is 2 root 10 meter per second is the speed of the bead once it reaches at point A. Hope you understand this. Thanks for watching my video. If you like it, please subscribe my channel. Okay, bye then.